In a previous video, I laid out the schematic of the MVCA, the Modulation Vca, which is one of the two VCAs in the Korg MS-50. The Korg MS-50 has another VCA that will only pass audio. It has some coupling capacitors in the audio path that would block DC, but then VCA can pass low-frequency signals. And I also added some power to it, and off screencast, I guess I should say, off camera, I added the inverter and the integrator. And so now that we have those in our schematic, let's actually lay out a PCB. So I'm going to do this somewhat improvisationally. If you're looking for a lot of slick editing, you will have come to the wrong place. I'm going to take the power and start laying it out there. So here's the power. Let's stick that in here. I'm going to use show V plus to see where the, let's see, I want to move this up so you can see what's on the bottom of the screen. So I'll slide, oh, there it goes. Okay. So there's the power. I will also have a couple of beads. So I'm going to use this move command a lot just because I know, kind of remember what there's L1, which is one of the beads. Stick that there. Move L2, which is another ferrite bead. I'll stick that in here. Let's move, I called it C100, which is one of the main bypass capacitors, the big electrics going into the board. Let's move C102, do the same. Now, of course, I don't have to move it with that. I can actually use move commands where I pick up a part and drag it. The yellow lines you see connecting everything, these are called fly wires. And at a given point, Eagle will try to run some sort of algorithm to connect the various things that need connected on the schematic to show you what those are using these little yellow wires. I think there's a way to tell it to keep updating that on the fly, but it's fairly confusing. So usually what you want to do is you periodically type rats to get the rat's nest command. And when you run it, it will update that. There's also a symbol somewhere in here that does that. I think it's this guy. This rat's nest, this thing that looks like a molecule picture in a chemistry textbook will run the rat's nest command. I want to pull in the various chips that are also of interest. And I like to place down my power, and then I pull in the chips. Do-do-do. 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 For this one, I only have 3 chips, so I might just have them running up vertically. But let me have them run sort of by the logic of what they're doing. So if I go back to the schematic, let's see which of these chips is the Modulation Vca. I want to put that in first. So that's IC2. So let's go back to the board, show IC2. That will make it bright. So I'll stick that down there and have that sort of be the first thing I take a gander at. And then if I look at the other 2 op amps, I know that one of them is associated with the inverter and the integrator. That's the 4558 here. It's used in both of those. And I know that the TL71, that just has to do with the integrator. So I'll put it up here by myself. Or not by myself, by itself. All right, so I have those things. Now let me look at the power. I'm going to use show V plus to look at the power. C100 was what goes with the... actually, let me do this. I want the bead, inductor bead. Let me put those up here. Let me spin it around like this. So V plus is actually showing up sort of at the edge of the beads here. And move this guy up a bit. Let me take my capacitor here. I'll take this one, flip it around like this here, and I'll do the rat's nest command. And now I sort of see how my power setup is going to run. The V plus is on the right side of the board, and the V minus is on the left side of the board. And let's see how that compares to, so my op amps all same sort of pattern. It's things on the left, or it's things on the right. V minus is all running along the left, so that's convenient. And then V plus is running along the right of all my chips. So that's kind of nice. Let's start to think logically about what the various things in the circuit are doing and how they connect. So I'm going to go back over to the schematic. I like to look at what the feedback resistors are and run those out of the output pin of the op amp. And I like to run resistors so they're kind of like coming out of the op amps like they're legs on a caterpillar or something. R10 is coming out of the output of 2A pin 1. So I'll say move R10. There you are, R10. Flip, flip, and I'll stick it here. I could put this close to here, but what I'm going to do for now is I'm actually going to leave a little spot to potentially run a trace in between there. Let's see what else we have. Going over the schematic, where else do I have a output? So this one actually, this is going to an actual trim pot. So we'll want to think about them especially. Let's go ahead and move. Let's see. Yeah, okay, so R13, let's maybe have that coming out of pin 6, the negative. So let's see how well that works. So pin 6 coming out of there. So let's move R13. Oh, move R13. There you are. Let's do rats. Make it easy to show what's going on. Flip it around. I'm holding down control to flip it. And again, I'm going to leave a little space to potentially run another line. The main thing that's actually hooking these guys up is the Vactrol. So let me move him next just to get a feel for how that works. So that's LDR1. So what I'll do is I'll just call this VTL1 for Vactrol 1. How about that? So I'm going to move VTL1 and let's see what hooks to what on the Vactrol. So this is hooking to the resistor here. Now which one is actually the resistor part and which one is the LED part? So this guy down here, I can type show and I'm going to click on this guy just see what connects. So this all connects. So this is part of that resistance network, as is this. Notice that the Vactrol sort of spans the two op amps on the two different sides of the chip. So what I want to do is make that a little more explicit. I'll move these guys up a bit. Let's take the Vactrol and sort of make it the centerpiece of the operation. Now that's interesting. If I do that, it crosses here a little bit. Do I want to swap around the role of which op amp is doing what? To try to sort of stay consistent with the original Korg diagram. Oh, wait a minute. But the resistor itself is symmetric. So I can do this. What I'm going to do is I'm going to delete these two wires here. I'm going to delete this guy here. Now I'm going to flip the symbol around. I'm going to mirror the symbol. Stick it here like this. Let's use net to wire this back up. And now I need to make this thing here a little cleaner. Okay, so let's move this guy over here. I'll use my split tool. That's kind of ugly now. But I can now move my V plus over here to go with the anode where it's supposed to. Let's wire all of that up. Save. I'm going to run electrical rule connect check again to make sure I haven't messed up anything. And now if I go back to the board and I type rat's nest, so now I've got a nice structure here in terms of what's hooked to one on each side. That's kind of pleasant. To make room, I will move the op amps for the other circuitry up a little bit. Now that I have that Vactrol somewhere I like it, let me do some work on some low-hanging fruit here. Let's work on the other op amps here. Oh, wait a minute. This one here is low-hanging fruit. I just have pin 3 to ground, so that's R11. Move R11. Spin him about here. There we go. So now it's nicely placed. That's R11. What other things do we have on op amps going to ground? That's an invert. That's an invert. R2 coming to pin 3. Let's go ahead and put that in somewhere. Move R2. It's going into pin 3. Again, I'm going to leave for now a little space to potentially run a trace in between here. R3 is coming out of pin 1. Move R3. Over here we have what comes out of pin 6. That's R5. Let's move R5. Pin 6 of this one is R5. Show ground just to kind of get a feel for where things are at. Okay, so no grounds are coming out at that particular moment. Let's see, what else do we have? This 10K trim pot between 1 and 5, so that's going to be important. Let's place that next, this VR1. Move VR1. Oh, that's kind of ugly, isn't it? Rats. Oh, wait a minute. Do I want it over on this side? If I put it over on this side, I think that kind of looks better here. What I'll probably wind up doing is taking this one and moving it over anyway, like this. So maybe I'll move this one in a little closer. Maybe we'll do something like that. We'll play with it later. There's another trim pot I should probably place. So there's one for the inverter. That is, let's just work on the inverter. So I've got RXX. Here I have a feedback. So this R33, I want to do that next. Move R33. And that should be coming out of pin. And then we'll have R39 coming out separately. Okay, so we'll have 33 in the feedback path. We have connecting to pin 5, pin 7 and pin 5. So connecting to pin 5 coming out here, it's coming to a trim pot. Let's do that. Let's move R36 and R39. So R39 I'll kind of keep separate. It's going out to the jack. And R36 we'll have come out of pin 5 and see how that looks. So let's move R36. Coming out of pin 5. And then what was the output one I said? R39. Move R39. Because that's the power is in the upper right anyway, so it makes a lot of sense to stack these two next to each other here. So so that would work out nicely. Let's ask ourselves, what about that other trim pot? What was that one called? Where should we put him? Let's see, there's R38. R38's the input, so maybe we should try to figure out where to do that. Oh, so here's R36. Let's do R37 and R35 just to see where they go. Let's do R37. So move R37. Whoop, I said move R37. It's coming out here. Oh, you know what? There's a bunch of space down here by the Vectral that we might not use. So maybe we'll put that here. Maybe leave some space if we want to bring a line in somewhere. So there's R37. There is now an R35 to ground in the trim pot. The trim pot's VR2, and there's an R35. So let's move VR2. Maybe spin it something like this. Yeah, maybe something like that. And then there was an R35, was it? R35. Move R35. Okay. Something like that, maybe. Let's see what other sort of things we have going on. Oh, I forgot to put down the bypass capacitors. So let's put down some bypass capacitors. So I've got C30 should be going on a positive, right? There's C30. And then I'll have, for the bypass capacitors, I'm going to go ahead and move those in more closely. Yeah, why not? Maybe I'll pull the resistors in later or have to pull these back. I don't think I'll need to, though. Move C31, so we'll use this to bypass the negative supply over here. Turn, 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 turn. Because we would like to get those as close to the chip as possible. So there was a move. Oh, I forgot. I'm not going to want to jam it up like that because I want to put a bypass capacitor in here. That's going to be move C32. Let's rest that one. Here's the bypass cap for the positive supply, and I'll move C33, and this will be the bypass cap for the negative supply over here. Now for the TL071, that had a couple of weird bypass capacitor values, so C1 and C3. So I'll move C1. That's going to, I think this is the negative supply, move C3. I would have to go look up the pinout of the 071 to remember. I don't use single op amps that often, so I don't have the pinout for that one memorized. Actually, we can tell real quick. Let's see. Okay, so plus is still on the right. I think we determined that earlier, right? So V minus is still on the left. Okay, so I'll bring this guy down here. Okay, so I have some bypass capacitors placed. What about other... the VR3, that's another trim pot. What is its role? So you show VR3. Let me just move VR3 to make it easier to find. It's this guy here. So it's part of the feedback loop with this R13. Move VR3. Oh, I don't have to, I could pick it up. Don't have to be fancy here. Let's move it over here. It seems to like to have something to do with whatever's happening over here. Maybe this one would go down a bit. I don't know. We'll see how this all fits, and let me go ahead and just kind of stick it there for now. See what else we have going on. There's VR10. What is? Oh, you know what? VR10. That is a variable resistor, but it is a front panel pot. I like to usually put the input and outputs in later because those are kind of at the edge of the board, and since we're big agnostic about it, we can kind of put things wherever. So a thing that we should probably do is beyond the chip, the next most important sort of center point is probably this transistor TR1. And it's kind of separate. It's driving the Vactral here. So let's do something from that perspective. And if we have all that circuitry over here, there might actually be an advantage of putting this sideways. Don't want to commit one way or another right now. Let's see, which one of these actually is hooked to the V+. It's this guy over here. So really the driving circuitry, well, if we already put this over here, there's no real reason we can't easily run a line through there. I don't think we're going to get trapped at some point. Especially because if I move this, I want a little more space to negotiate what's happening here. So I'm going to group all of this stuff together and just move it up a couple of notches. So then I have some space to negotiate how we're connecting up with the Vactral. Let's go back to the schematic and see what hooks up to the Vactral. Okay, so there's an R15 that goes to the transistor. So let's make that the connector. So we'll move R15. Here it goes. So if we put it here, it nicely comes out over to the transistor over here. And maybe put the transistor, let's stick it there. And what's coming out of the base, that's going to be some inputty things. So we'll see what we have going to it. Okay, there's the diode and R19. So let's do that first, D1 and R19. So if I go over to the board, I'll say move D1, rats to connect things up. So that's going to the base here. And then I've got move R19. So that's also hooked to the base. And when I do the rat's nest command, that becomes clear. Yeah, sure. We'll put, let's put that there. What is the input resistor here? It's R17. Let me go ahead and put that in. So move R17. And we'll see what we want to do here. Let's see. Now the emitter has some stuff hooked to it. Let's check that out. R16 and R8. So it's R18 and R16. We'll say, let's go move R18, move R16. Yeah, I like the way those connect up. That looks nice. Let me move, I want to move this up because I don't want this to look like it's logically part of the op-amp circuit, because it's not. It's sort of doing its own thing. So let me move, just to make myself happy. I'm going to move all these up here. And I'll move this up one other notch. And maybe move that over a bit. There we go. I like that. What else do we have left to deal with here? So we've got inputs and outputs. We do have some resistors. We've got R1, R4. Let's deal with R1 first, because I think that was connected to a trim pot. So if we go over here, it's connected to the base here, and that's probably hooked to some voltage supply. Let me move the indicator of what this is up, and I'll put this maybe here. Oh, there is a big error. There's a big error. Let's fix the big giant error. This op-amp, the inputs need to be switched around. That's why that was confusing me. I'm going to delete this, delete this, delete this, and delete this. Many moons ago, I worked on a circuit. It was a adaptation of the balance modulator in the booklet music easel. And there's 12 op-amps in it. I used 6 dual op-amp chips. And I sent it off to get manufactured. And then later looked at it and realized I had the plus and minus switched on every single op-amp. I did build it as a prototype. I wound up bending the pins upward and using wire wrap to cross as it went into the board, but that was a deeply painful experience. So I'm going to mirror, rotate it twice, and now when I net this guy back up, here we go, beep, beep. Now the negative is in the right spot. So R36 goes up here. Move RXX. So that's all making sense now, finally. What other resistors do I have in here? I've got R12 and R4. So what do you do? Notice I'm always going back to the schematic, trying, not just plunking things on the PCB willy-nilly. I'm trying to think about the logic about how the circuit's operating. Move R4. This is my usual trick to quickly find where something is. Oh, this is just at the input. There's nothing magic there. So let's find R2 and hook an R4 to it. Let me go back here. Move R4. That hooks up to R2. It's actually a hookup to ground. I might move this up a bit because this, I think, is wired as a buffer anyway. Move this up a bit. Move that here a bit. Maybe move this down. Sure. What does R12 do? Show R12. Let's actually do move R12. So it's at the input here. It's coming in. We could put it in pin 2 of this guy. So let's go to move R12. And that's coming in. So I could put this a couple different places. So this is part of the feedback there. And I could put this, or I could put this up here. So I do want to think about this maybe more as, maybe I want to do it like this. So I'll think about the negative coming in this way and see how that winds up working. I've got the various inputs and outputs. I think those are the only things that are left beside this front panel pod. Oh, R38. What do you do, R38? Move R38. That's part of an input. It goes into pin 6 here. These input resistors, I often will change around how I want to interpret where they are, what they're doing, etc., etc. So I'll stick that here for now. And let me move some these. Actually, let me do the pot next. So let's move VR10. That's part of the integrator, which I think is part of the structure up here. It's part of actually connecting these bits of circuitry together. Now, this is a front panel pot. I do want to sort of call that out as a special thing. So maybe I'll stick it up here. Maybe rearrange some of the stuff later. So what about the inputs and the various outputs? So I have a inverter input. I'll just move inverter in. I think it comes off this side of the board. And then let's move inverter out. Let's do a rat's nest and figure out where that wants to come from. So that comes from up. Oh. So that's maybe not an ideal place for that resistor. Let's stick it here. And it would be nice to have these. I could stick it like here. That looks kind of nice. Let's do that. Then I'll maybe move this one in a bit. All right, so what about the integrator? So I'll move int in. Let's see, where does it want to go? The signal for the input to the integrator wants to go over here. If I've got that guy there, maybe I'll probably want to do something different with him later anyway. But let's put this here. So there's the input. Move int out. And the output of the integrator, let's put that up here. Remember, the idea here is we're going to run fly wires from the PCB to the front panel. And then the other things I have going on, I have, sen is the input to the VCA. S out is the output from the VCA. There's that 22K. That's part of the feedback loop. Would be nice to have this not all gummed up like that. So maybe I'll move the trim pot down here. Maybe move this guy over, something like that. See what's happening here if I do it like this. Let me flip it, just because it looks nicer. Although, I don't know. I may change that around. Oh, there is a modulation in, right? A control voltage in to this VCA. Move CN. And, okay, so that's coming in through R17. Right, okay, so he's actually up here, isn't he? Oh, C2. What do you do, C2? Show C2. That's the integrator cap here. That's 1U. And so that is a non-polarized cap. That's probably a fairly good-sized cap. Let's see what should go to what. What I'm going to do is I think I'll put it here so it's got some slack. There's some space, because if this is a non-polarized 1 microfarad cap, that might be sizable. So I have what I think is probably a reasonable layout for the various parts here. I'm going to delete that thing that says POW, because we know that's power. Move that one, scooch that in, something like that. Or maybe that's a little too close. Depending on what kind of connector people add in here. This is a Molex connector, and who knows, there could be different sizes. But we have something that's resembling a reasonably decent layout. I think at this point, you could do a couple of things. One is you could start going back to the schematic and adding a lot more from the MS-50. That might be kind of fun. But for the exercise now of just showing how things can be laid out, I think I will cap it here. I'll back out a bit. And if you're one of my students, as long as you're doing your project within the scope of this board size, I'm happy. Don't feel like you need to be as intent on trying to compress the design down as I am here. Let's see, so let me scoosh. I'm going to just group and scoosh the whole thing over here. maybe we'll bring in the top and bottom. So, that was not very... Let me undo that. Okay, that was kind of terrible. Oh, I don't want to grab the corners. I remember now. You want to grab the edges here. Oh, did I mess that up in some way? Let me zoom in. See if I got a category. It should be smart enough to know that you probably do not want some weird rhombus board or trapezoid board or something that you would just like a rectangle. It should not be that difficult to figure out. I'm going to scoot the top down just a little bit. And let me pull this in, something like that. You know what? We could probably pull this in even a little bit more, just to kind of stay consistent with other stuff that's going on. Let me see if I can get... there we go. Maybe I'll do something like that. And then these are all kind of lined up nicely. Stop beeping at me. Silly computer. And yeah, I don't know why. I just like the way this looks, having the various ins and outs lined up on the edge like that. That makes me happy. Let's see. Let's maybe put this like that. And then we'll grab the edge of the board here. Maybe pull that in a little bit. See if I can do this without making a giant mess. Okay, that seems to not look like a giant mess. So let me zoom out a bit. Let me save that. And what I'm actually going to do is I'm going to save this as another file name because I might want to go in and, I don't know, do this a totally different way later or something like that. I'll call this MCA2. At this point, I have a pretty decent candidate layout of parts. I might want to move these around, and I'm going to start routing things. Now, especially when you first get started with circuit board design, PCB layout, I strongly recommend don't use the auto router, and also turn off the various routing helper tools. Like here's walk around obstacles. This will tend to really get those traces close to the parts, kind of winding around, but it can make it hard to follow what's happening. So I want to loop remove, just turn off. Actually, that's new from last time I used Eagle. I'm not sure what it does. So I'm going to put this on ignore obstacles. So we're not going to push obstacles or walk around them, doing this very manually. And the reason you want to do this is that you will often have a very terrible layout of parts, and until you get some practice with it, you won't notice it if you use something like an auto router, and you'll be going all over the place. The other reason, if you do a layout by hand, you sort of get an opportunity to spread the traces out a bit in a way that makes it easier to debug the circuit later. So you can see on both sides of the PCB, you can see the traces and follow what's going on. If you made a mistake in the layout and your traces are kind of spaced out a bit, you're more likely to be able to cut a trace if you need to without damaging another trace. Also, if you spread things out a lot a bit, you can use various Miller machines, or you can use some sort of photochemical process and probably have better luck than you would if everything's kind of jammed up. Now, if you're getting the board professionally made by a professional board making house, none of that's really a problem. I like to turn all of this off just so you can be really explicit about how you're routing things. So when you're routing things now without those tools in the auto router, it forces you to think about the part layout. And as you're routing things, you might make a change in decision about where you want to put things. So the bottom layer is blue, the top layer is red, and I'm going to start on the top layer. I'm going to start by routing out just the power supply connections, because here I don't think there's that many of them. So I'm going to say show V+, and I'm going to say route air wire. So you're never actually drawing traces directly per se. You're always going to be dealing with an air wire, so that this is sort of keeping track, Eagle is keeping track of how everything locks to the schematic. This default width in Eagle is insanely small. For a through-hole board, for signals, I like to use 16. For power and ground, if I can, I like to use something like 32. I've also used 15 and 30. Let's go with this. So I'm going to use red, which is the top layer now, to route the power. So I click on an air wire, and so I get together like that. If it's something like these capacitors where the pin isn't really on a nice grid. I like to click over on that side so it starts there and then ends somewhere else. So click through like that. So I'm here, I'm using that 32 for the power. Let's do, okay. Here's the power that goes up to this chip. Now I could run the power down the middle. I think here I would like to run it down the outside here a little bit. So we'll kind of put it in through like that. And so my mental model for this is that the power is coming out of the bead. And this guy over here is just kind of doing some, well, not actually sure what the best conceptual way to think about that is. Ignore what I just said. How about we'll do something like that? Does that look pretty? That looks pretty. All right. So now we need to do the same thing over here. And we'll say it's coming to the, actually, let's see, these are close enough. Yeah, we'll go ahead and just kind of keep that way. So redo. This guy I'll route over here. Again, I'll kind of click up here and we'll split up there like that. There we go. There may be some detailed theories about why you want to connect to this, that, or the other, but that's audio circuit. It doesn't really matter much. Okay, so the V plus here, sort of coming out here. Let's stick on here to the Vactral. Have it branching out of here. See how the power kind of branching out like in this tree structure. It doesn't really much matter for something like this. Just because it looks good. How about we'll let this one run down the middle. There you go. Something like that. I could probably put this closer to the pins, but if I don't have to, I might as well leave some space. V plus. So it'll be very convenient to then come from here down through here, something like that. All right, so I think I've got all the V pluses installed that I need. What about V minus? So let's show V minus. Let's go up this way. We're hooking to that resistor here. Show V minus. Who else wants V minus? You want V minus. So what I'm going to do is I'm going to kind of route it in the middle here like this. And then come down here like that. Okay. Now it can get a little tricky because Equal will get kind of confused about what your intent is. So I'm going to click here, go there, click here to go there. Okay, now it's convinced. Sometimes you'll see an air wire over a trace, so it's gotten confused. And you would have to kind of go in and do something manually. Now, there should be some other needs for some minuses further up here. Okay, so there's one over here. Let's do it this way. I'm going to route. Oh, it looks kind of nice coming up from there. Or I could go like this. I'll just go like that. Route into the chip. Now, I could take this guy here and spin it like this. I like that. Yeah, because now I can run the power, I'll run it here like that. There we go. Did rat's nest. Show V minus. I think everybody that needs a V minus got V minus. Okay, so I use the top layer to put in the main power to everything and sort of have these two little veins and arteries going up. So let me switch over to the blue layer. That's the bottom layer, and that's where I like to generally put ground if I can. Now, I will switch layers if I need to. If in order to make the routing work, if I need to temporarily switch one of these to the blue layer, switch top to bottom or bottom to top, I'll do that, especially when it's convenient to make those transitions at a particular junction point. Now, in general, I try to keep things on the same layer, and I try to avoid putting in a lot of vias where I switch one layer to another where there's no through-hole part where I'm doing that anyway. Especially compared to the auto router. The auto router will just kind of throw vias everywhere. And the reason I like to do that is when you're debugging the board, when you're actually sitting on the workbench with the board, if you have to flip the board over and over to the top and bottom and look at each side to trace a signal as it's going up and down through the different layers, that can get very confusing. So I try to keep a signal on the same layer as much as I can. So here again, bottom layer, routing a trace. Let me see if I can route some grounds here. So the two middle these are both connected to ground. So what I'm going to do is I'm going to connect it through kind of like this. Then I'll connect through like that. Okay, so that these two are connected over here. And now I'm going to sort of really emphasize then doing the same thing. Now, see, this is a little weird. Why is it wanting to go all the way down there? Okay, I think it's happy now. And what I like to do is have the ground go out as a tree structure. Now, in audio circuits, you generally don't see people use ground planes. You see people use ground planes for digital logic, certainly. And I've seen circuits where there's sort of two different sections, where there's like a digital section, an analog section, or maybe there will be different ground planes that are sort of like connected at a few choice points or something. But for something like this, I generally do not see people use ground planes. And you can Google that and go to forums and go down a rabbit's hole for ages about the pros and cons, about whether, okay, is a ground plane forming a audio ground loop on your PCB? Is it acting as an antenna? What about the low impedance? Well, of course, then people say, well, a chassis on something like a tube amp, that's like a giant ground plane. I'm just going to go with a couple of ideas. One is I generally don't see people use ground planes on audio circuits, whatever the reason. So I stick with that. And the other thing is I personally find it very helpful to see where the ground is going. And if you have a big ground plane, it's just kind of magically ground appears where it needs to. But when I look at a circuit board, I like seeing the logic of where the ground plane is. So I'm going to use show ground. See what's ground. Don't want to create a loop, but I will have a tree that kind of comes out down the sides of the board. And then I could use blue in the middle for moving signals around as I need to. I'll take this, there's a ground here for the capacitor. Let's do something like this maybe, right? So I'll put it here. Let me move this over a little bit. Routing down like this. Let's route down a little more, kind of like here. I don't have to go down quite that far. Yeah, this will give me some extra spot. And here I have, okay, so now I routed a ground starting up here. And the reason I did that is now other things that need grounds, I'll just kind of pull off this little trunk here. And so it kind of makes this little tree star-like pattern. Can do something like that. Don't have to be too fancy with it. Doop. Doop. This guy here. Doop. This guy is also ground. I'll just kind of... So he's a ground. Who else wants a ground in here? Let's see. This guy wants a ground. So pull him down there. So there's a nice ground coming out of there. Who else wants a ground here? This person wants a ground. Again, I can do this thing and it'll come out like this tree structure. Who else wants a ground? Let me look on the right first. Okay. This person wants a ground. We'll just sneak that there. Or actually, I'm going to Control Z that. I like the idea of doing, let's do this. Don't ask me why I like that better. I have no idea. It just makes me happier. Show ground. Can get a ground from here, or I could pull it. Then I've got a little space. Let me move him down a little bit. Just kind of leave some more space in there. Who else wants ground? This guy over here wants a ground. Could just kind of make this look a little more elegant. Because I could use red to do those crossings. I'll probably do that later, and we'll just stick that there. Okay, so these guys have grounds. And this isn't a supercritical. That's a bypass path. Okay, so those are some grounds. Let's go over to the other side here and look at who wants ground over here. All right, so there's a ground way up here. Now, I don't want to make a ground loop here, right? So I'll go Down here a bit. Keep going down. Oh. I could probably make that a good deal more compact. So let me play with that for a second. So I'm going to stop this ground here for a moment. Doop. Okay, stop there. I said stop. Because I've got a lot of space here. So how about, what if I were to take this 10K here and move it something like this? Especially if that's ground anyway. Let's see, how does this work? Let's kind of connect. Oh, you know what? I might as well just put this here. Right, we'll put him here. That makes a little space for this guy to go here. I like that. And then we could put that there, sure. It's not perfectly lined up, but it's kind of nice. Let's move that a little out in case somebody is using some sort of fancy connector here. And then if we're doing that, let's say, what if we actually just put this here? Nobody else is using that slot. I can move this whole thing in. And again, I'm being a little overly pedantic about trying to compress this thing down. It just feels like it has some elegance when you do that. You know, are these things lined up now? Pick up this trace, move it up there a bit. Move it up there a little bit more. And actually, you know what? It's going to be hard to get the flywire to do what I want, so I'm just going to go ahead and delete that trace and rerun it. So this goes down this way. I'm going to run it all the way down to here, let's say. And then, oh, I can leave some space in there. I could run it, yeah, I'll run it all the way down to here, kind of like I did with the other one. Okay, and then he'll attach over here. And maybe I'll clean up this guy a bit. Let me just run him a little bit one over, just for safety's sake. There we go. I like that. Okay, so I've got 59 air wires left. So let's show ground again. Let's put in some grounds. Pulling out in this little tree kind of fashion. Who else wants a ground? You want a ground. And a bunch of people. Let's see, okay, those got grounds. This one, sure. So I've got nice low impedance paths here. Now, you could make an argument, is there a capacitance between these two traces that would create a problem? I don't know. These guys need grounds. Okay, that's a little tight, but it still works. There should be enough clearance here. Show ground again. I missed some. Here it is getting a little bunched up, so I'll go ahead and route this guy here. Route this guy here. And then I'll route this guy here. Okay, now everybody who wants to have a ground should now be having a ground. These guys all have grounds. And, oh, this guy needs ground. Ground here. This guy wants ground. And this guy also wants ground. Actually, he can come from over here if he wants. Sure. Okay, so a bunch of grounds have been placed. And no, there wasn't any particular logic to how I did that. Now, I'll move grounds around. Or I'll move power around if I want to. So I want to go to do the signals. I just generally like to have everything on the bottom side, including signals if I can. So I'm going to start by routing things on the bottom side. Now, since I'm going to signals, I'm going to switch to a smaller width, like 16. I've also used 15. And just kind of do the low-hanging fruit here. Let's see, I'm just going to pick some, let's see, so this guy connects up there. This guy connects over here. Oh, let me be careful about how that connects. So now I'm going to be very careful about this because he's part of a, you can do this. You can run a trace between two pins like this. And I want to be very deliberate when I do that. So now I've got this, so I can run this guy here. But now to make that work, I'll need to switch to the top layer for this one. Okay. Let's keep going. Signal going in from an outer jack, you know, those outer pins. Like this one, you know, is going to go there. Okay. This one comes here. This one goes there. So those are all routed. So I'm going to keep typing rats for rat's nest, and that will tell me the number of air wires. Here I have 39. So that's an indication of how much more work you have to do. Okay, so let's keep working on some low-hanging fruit. These guys connect. This guy connects. These connect. This guy connects. A bunch of these are going to have to go to... Actually, if I want, just... What do I want to do here? I really kind of want to keep this trend of keeping those blue if I can. So I may do something a little different here than usual. Oh, you can't delete traces. What you want to do is you want to rip up. Use the rip up command, which is also this guy. If you want to get, let me route this as blue because I really want to kind of keep signals as blue. Blue, 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 blue. Because they have to go through here. Okay. That works. That works. This one, so this one I can go here like that. Or like this, doesn't really matter. Yeah, that's good. And now I've got, oh, okay, I have this one route. Where does he go? He goes down here. So he's going to go kind of parallel here. He's going to come back here. And then I will route here. This guy goes there. And I could do this either direction. I could have gone like that. You know, any of this works. Now, what do I want to do with the ground there? If I really want to keep it blue, you know what? Let's do this. This is going to be fun. So it's not the shortest path, but it both satisfies my internal need to have grounds be blue and like to have signal be blue. Now I could use red here and make it shorter, but I don't think there's much point. There we go. And again, this is solely because I really like to be able to look at the bottom of the board and see as many traces as I can. Obviously, I have used the upper layer, not just for power, but some other things. But this way I can sort of see things all together as much as I can. All right, let's see what else we can do with blue at 16. Okay, for signals again. Simple signal routings. Okay, so there's one. Let's see, what does this one do? Oh, he comes straight down there. And again, this isn't necessarily for the logic of the operation of the board per se. This is for being able to get a sense of just looking at the board when you're trying to debug it and things like that. Okay. Let's see how much more work we have to do with the rat's nest command. 24 air wires. Great. These guys hook up. I could pull all these in tighter. Again, I like to kind of keep things separate. It's just going to make manufacturing easier if somebody wants to use some sort of weird process on this. Okay, now we're sort of in the tricky zones. I'm crossing over the chips, so I want to be very careful about not crossing with the same color. These guys hook together. This guy hooks to this transistor. Transistors tend to be kind of weird, so I like to route these coming out of the transistor. You know, anything where the pinout doesn't line up on the grid nicely. Nice little T-junction there. Now, there may be some theories about maybe this should be a Y-junction or something like that. For rock and roll here, this should all be fine. Link all these guys together. Okay. Right, I could also do it like this. I could do any number of things. I think this will work. Because maybe there's a situation where the source should split into two signals. Don't think it really matters here. What was this doing anyway? Oh, it was connecting these to grounds. Oh, wait, was there a ground I didn't know about? Oh, no, because this is the 1K here. Oh, let me think about what this was doing. Okay, this was a case where there's a negative voltage needed on the right side of the board. Since I'm doing that, let me use info. So here's a case where I am using the blue layer to send voltage without having to mess up a bunch of other stuff. So just very temporarily on this blue layer, and again, there's no particular reason. I just like doing it this way. There you go. 32, right. Okay. So this is a visual indicator to me by the fact that we've increased the size there, that this is now a higher voltage. So I'm also going to do something a little strange here, which is I'm going to hold down Option. No, that's too tight. Let me adjust my grid settings. So so I can set grid settings. I've got size, multiple alt. I'm going to set the alt to 25. So that's half. So I've got my big junctions where it changes a lot, but I can also hold down Option and have it change half of that. Now, I don't want to do this willy-nilly, but I'm doing it here just to get kind of a little more clearance here. Again, a professional board house would have no problem with this, but if somebody is trying to fab this on their own, having a little bit of extra slack helps. So let's go back to routing signals now that we've gotten this taken care of. And again, I increased this to 32. So this, even when I'm looking on the back, realizing maybe it's not a standard signal. It's not, might be ground, but here it is a power signal. It is another visual indication of that. Let's do rats. 13 air wires. Oh, that's so exciting. Let's see, where are the remaining air wires? Ah, there's a whole bunch of up here. Some of this I might want to redo in different ways. Well, let's see who wants to go where. Okay, this guy wants to attack to that pin. This guy wants to go over to this pin. And let me do something like this. I don't know why. I want to zigzag in the middle there. I just think it makes me happier. There's no reason. I just like zigzags. These zigzags are just kind of fun. Let's see. This one. This connects up here. Sure. Let's zigzag. Let's have a zigzag party. What else is happening down here? Ah, we've got some things where I think we will want to switch to the other layer. Oh, here's a signal. Connecting theirs can connect fine. Again, there might be different reasons you might want to connect it like that or something, but this is fine. Okay, so now I'll probably want to be switching layer to the red layer to do some of this. Here, this is... I'm probably going to be using red to get up there anyway, so I might as well just use blue here. Okay, so that's routed here. These two are connected together. And, although, wait a minute. Where does this guy actually go? It goes down. Okay, he's going to have to be red anyway. Let's see. I might switch some of these later, but let's go ahead and run this guy along the top. So he's going to come down here, have him slide over here a bit, and he wants to go down to there. Okay. Maybe I'll have it come out a little bit more just for fun. Have it jet out a little bit, just to be fancy. And now this guy here, we'll probably want to loop him. Now where does he go? What I'm going to use the show command, and I'm going to click on this now to see where it wants to go. Okay, so it's coming from here. I think that's an output resistor anyway. So I think what I'm going to do is I'm just going to move that guy. So I'm going to use rip up, get rid of this trace, and just move this resistor closer to where it needs to be doing its business. Let's see, these are all jammed up together. Oh, what if I did this? It's not. So that was the most elegant. I'm going to use that option to sort of put it in between. So now if I do rat's nest, oh, I need to turn it. So let me pick that up, rotate. Right, so it's just a little bit off. It's coming up here. If I had thought this through earlier, I would have had come up with something more elegant for this. What if I did this? So I'm going to take this, and this is what I meant earlier about how it's very useful to, so what if I sort of use this to bridge those categories? So now I can have a blue line route here. And this is now the output. It's coming from up here. I'll show you what I'm going to do. So it looks like I'm crossing the lines, but this is just temporarily. And now I'll make the sequence in here red. All right, so what I'm going to do is I'm going to use info. Sometimes it's just easiest just to rip it up and redo it. Now, the funny thing is, as I'm using info to change this, you'll see vias appear. But now if I do it on this one, switch it to red, it disappears. Okay, so I'm going to switch this guy to red. Switch this guy to red. Since these two are tied together anyway, this is kind of, I could do it like this. I do it like that. That just looks more fun. All right, so I've got 3 air wires. Where are the remaining air wires? I've got this guy. I can switch to red just to handle this little case. Going over the ground there. 2 air wires left to go. Oh boy. If I do a design rule check, will it tell me? All right. Here's one. I'll go back to blue for that. Nope, I said blue. Blue. Why don't you want to be blue? Let's do blue. Okay. And then where's the other air wire? This one. So this one's just blue. I just didn't get around to routing him. Do. Rats. Nothing left to do. Great. Look upon my works, ye mighty, and despair. Now that I was able to clear off that space over there, let me group all of this and squish it over. And then I'll scoosh this over. Scoosh. All has been scooshed. So I'll save here. And let me do a DRC design rule check. And it's not complaining about anything. So I'm going to save this, and I'm even going to save another copy. I'm going to save as board 3, in case I want to go back and in case I had messed up something. Now, one thing I like to do is actually go back to the schematic and do another error rule check to make sure just I did nothing weird. One thing as a side, it's very important once you create this board that you always have the board file and the schematic file up at the same time so things stay in sync. Now there is a useful command, I haven't need to use it here, called replace. It also works on the schematic. So say it turns out that you said make the board and you have a whole bunch of resistors over here that you're expecting to be through hole. And instead it turns out, oh no, they're surface mount devices. Well, assuming that Eagle can successfully match up the pins in a logical way, you can use a replace, give it the part you want, and then go in and click on a bunch of, I'm not sure what that did. Control Z. You can then click on a bunch of parts and replace them. That doesn't always work. Sometimes it can't figure out the pin mapping. And that replace command is also one of the few commands that you can do on the PCB, and it will sync up with, it will fix the schematic to sync. Most things like trying to delete trace instead of ripping it up, or delete a part on the PCB, Eagle will complain at you. It generally wants to make changes to the underlying circuit. It wants you to do that on the schematic and just use the PCB side for just placing and routing parts. But the replace command does intelligently work over here and match up with the schematic. So let's just zoom in and take a look at our handiwork here. Okay, it's kind of a nice logical layout. I want to clean up the silk screen, but let's do that in a different video.